Today we're going to learn about the trapezium rule.
We use the trapezium rule to find the area under a graph, between the graph and the x-axis. And we'll do that between two limits, as you can see on our example. Now, if we're going to find that area, usually we would integrate. And the trapezium rule is just gives us an approximation. It's a bit like the mid-ordinate rule or Simpson's rule. But it's one of the methods that you need to know about. And it is very useful when perhaps you can't integrate the function for whatever reason. Now, to carry out the trapezium rule, we split the area into strips, and each strip is going to be formed into a trapezium. Each strip we've got the two vertical sides, or the two parallel sides of the trapezium, and the base of the trapezium is the x-axis. Then at the top of the strip, we join the 2 points either end of the strip to each other. There we've got a trapezium number 1, number 2, and trapezium number 3. So what we're going to do is we're going to work out the area of each trapezium and then find their sum. Now, if you look at the trapezium on the left there, you'll see that there's an area which is above the curve but is included in the trapezium. And the same is true for all these 3 trapezia. And because we've got a convex curve, then the trapezium rule will give us an overestimate for the area. If you look at a concave curve as well, curve the other way up, we've got the 2 trapezia there, and we can see this time actually there's an area under the curve which isn't included in the trapezium. And so when it's a concave curve, the trapezium rule will give us an underestimate of the area. Okay, let's use the trapezium rule to estimate the area for our example. So, find the area of trapezium. You should know how to find that. A nice way of putting it is half the sum of the parallel sides times the distance between them. And so we're going to need to work out the y values, the height of the verticals on the trapezia. Divide that by 2 and then multiply by the strip width. So we'll work out the strip width first. And just a note, we've called the verticals y0 and y1 in our formula there. There they are on the graph marked. So calculating the strip width. On our example here, it's really straightforward. We can see each trapezium has a width of 1 unit. But it's not always so straightforward. You might not have the diagram. So it's useful to know that the strip width is the difference between the 2 limits. They're marked on as A and B, divided by the number of strips, or the number of trapezia. And so our upper limit is 2, our lower limit is -1. So the difference between those is 3. The whole width of the area is 3. And we want 3 trapezia, so we're dividing it into 3. So the strip width is indeed 1. Next, we want to find out the y values. But before we do that, we need to decide what our x ordinates are. We'll calculate our x ordinates. We're going to make a table of values. So our first x ordinate is simply the lower limit. And then we're going to go up 1 strip width. So in our case, that's adding on 1. We're going to carry on adding on the 1 until we get to the upper limit. There we are. We've calculated our x ordinates. We can find our corresponding y ordinates. We do that just by using our function x squared plus 1. So we'll do that for each x ordinate. We've got them. Okay, let's finish off. I've labelled y2 and y3. We've got 4 y ordinates and they're all there on our table. So what we could do now is we could say, right, we know how to find the area of the trapezium. We know the heights of each point, or the lengths of the parallel sides, so we can simply work them out one by one. And we could do that. There we go, we've subbed in our y0 and y1 into the formula, as well as our strip width. However, there is a formula that we use, and I just want to show you how we find that. That's the area of our first trapezium, and we want to add that to the area of our second trapezium and our third trapezium. Notice that the y ordinates are different on each of those. And what we can do, we can combine this into a simpler to use formula. So for each of the three trapezia, each time we've multiplied by h, the strip width, and each time we've also divided by 2. And so we can take a factor of h over 2 out of all of them, which you can see on the formula at the bottom is what we've done. Now, if you look more closely at the y values in each formula, if you look at y1 on the first one, in the first trapezium area, you can see that it's repeated in the second trapezium area. And so we've got 2 lots of y1. And then in the second trapezium area, we've also got y2. And that's repeated in the third. So we've got 2 lots of both of those. But the y0 and the last one, y3, we've only got one of those because they're on the ends. They're only part of one trapezium each, whereas the ones in the middle, they're part of 2 trapezia. Formula in the textbook generalizes this further. There we are. So on the bottom in white, we've got there a clipping from the formula booklet. That's what it looks like. So, but the one, the second formula down, that just generalizes what we had on the previous slide, where the only difference is that instead of having y3, we've now got yn, meaning the last y value. And then inside, we've got the sum of all the y coordinates from the middle of trapezia up until the penultimate y ordinate. One way of remembering this is to say it's the strip width divided by 2 times the ends plus twice the middles. So we can now sub in all our y values rather than working out 3 separate trapezia to get their total area, which works out at 6.5 square units. Now, not quite finished. Let's just have a think about the accuracy of this. So what's the relative accuracy of it? How accurate is it? So we've just worked out the area, and we can also work out the area of this area using integration. So either work it out by hand or on your calculator, and you get a value of 6 square units. So the actual error is 0.5 out of 6 units, which gives us a bit of a meaty 8.3, 8.33%, which is quite an error. However, we can improve things. We can improve our approximation by increasing the number of strips, number of trapezia. So the diagram on the right is the same function, x squared plus 1. It's the same limits, but this time we've divided it into strips of half a unit width. So that means we've doubled the number of strips. We can use our formula. We can work out the y ordinates. Our strip width is 0.5 now, so 0.5 divided by 2 at the start of the formula gives us a quarter. But we can calculate that out, and the area using this rule, there we've got a 6 and 1/8. Compare that to the area using integration. We've seen that already. We can work out a relative error of much smaller than before.